Welcome to Science with Robert, a YouTube channel dedicated to sharing science with you in a fun and interactive way. Enjoy!
Taking advantage of surface area is not only amazing, it can be powerful. I wonder why there has never been a superhero named after surface area. Surface area and away! Well, maybe that's why. If you take a three-dimensional object and spread its surface out into 2 dimensions, the resulting total coverage of all the sides would be the surface area. For example, all the sides of this cube and this cylinder are covered in red tape. When all the tape is taken off, the coverage of the red tape is the surface area. Surface area plays a very important role in many chemical and physical properties. Let's take a look at a few examples. When you slide 2 pieces of paper together, the friction you must overcome to get the paper moving in the first place is called static friction. It appears relatively easy to pull these 2 pages apart. However, how hard do you think it would be to pull these pages apart if we increase their surface area by a factor of 140? Dr. Smith has 2 70-page notebooks. He is placing a page of each notebook on top of the other and doing this for the entire notebook, thereby increasing the overlapping surface area by 140. He is being careful to keep the holes of the notebook paper lined up because he will be needing the holes later. The force of static friction will definitely be greater, but just how strong will it be? It does appear the notebooks are hard to pull apart. Dr. Smith is now placing a tow chain through the center hole on each notebook. The 70-page interweaved notebooks are now between 2 vehicles connected by tow chains. Dr. Smith is going to try to tow the brown vehicle with the yellow vehicle. He will be towing up a slight incline for safety purposes. Let's see if this will work.
No way!
There is no way this is gonna work.
Scientists have known about this for some time, and they believe it is not only static friction and surface area at play here, but it is also that as the notebooks get pulled apart, the middle section of the notebook gets pulled together, which also amplifies the static friction.
You better hurry up and get your car, Dr. Smith.
Liquids cannot be compressed, so they are excellent carriers of a shock wave. Dr. Smith is filling a glass bottle almost to the top with water. He is then going to strike the top of the bottle with a rubber mallet. The rubber mallet compresses the air inside the narrow neck of the bottle, and this shock wave travels to the water and increases the pressure on the water. Since water cannot compress, this force instantly gets equally distributed to all parts of the water in the bottle. Since the bottom of the bottle has a large surface area, the force is enhanced at the bottom of the bottle, and the bottom pops out. If you want to try this demonstration of surface area, be sure to take all necessary safety precautions.
This is what happens when you run out of glass bottles.
So far, we have seen physical properties enhanced through surface area. Now let's take a look at a chemical property that gets enhanced through surface area. Dr. Smith is attempting to burn piles of cornstarch, ground cinnamon, and iron filings. He just can't get piles of these substances to burn. He can get the cornstarch pile to burn a little bit, but it quickly extinguishes itself. The problem is not enough oxygen. Dr. Smith is going to greatly increase the surface area of each of these powders by turning them into a powder cloud. The powder cloud should ignite because now oxygen from the air is much more freely available to allow combustion to occur. To make his powder cloud special effect gun, Dr. Smith is going to use a 3-foot length of 1/4 inch tubing, tape, a funnel, knife, and a barbecue lighter. He first tapes the tube onto the barbecue lighter so that the tube is slightly lower than the end of the lighter. Now notice that the funnel will not fit on the end of the tube, so Dr. Smith uses the knife to cut and peel away a short piece of the tape to allow the funnel to snugly fit on the end of the tube. In order to pack his powder cloud special effect gun with powder, Dr. Smith is mixing a small portion of cornstarch with ground cinnamon. The ground cinnamon is actually not necessary. Later, you'll see why Dr. Smith is adding it. He pours the mix into the funnel and taps the top of the funnel to get the combustible powder into the tube. After removing the funnel, and in order to fire the powder cloud special effect gun, Dr. Smith is being sure to hold the gun so the flame is going upward over the opening of the tube. He then blows into the other end of the tube and...
Whoa! What does that look like at night?
It's pretty awesome. But first, this is what a powder cloud looks like that did not burn, because Dr. Smith was not holding the gun in the correct orientation. These ignited powder clouds contain only cornstarch. This is what ignited powder clouds look like that contain cornstarch and ground cinnamon. This is what ignited powder clouds look like that contain cornstarch and iron filings. Let's review. Surface area is the total coverage of the surface of three-dimensional objects. Surface area can have a large impact on chemical and physical properties. Liquids cannot be compressed, so when a force is exerted on the surface of a liquid, the applied force gets equally distributed to all parts of the liquid and exerts more force where there's more area of the liquid. Combustion of solids is enhanced greatly by increasing the surface area, as shown when using a powder cloud special effect gun.